Hello, I am Firyuza and you are watching Bold Science with Firyuza. Today's topic is quite difficult, but I will try to present it as clearly and simply as possible. For many people, general relativity is sacred. It is not customary to treat it critically. It is not allowed to doubt it. It has become a dogma. And the main argument its supporters use is always the same. It has stood the test of time. It has been experimentally verified. What is almost never mentioned, however, is that general relativity has not yet passed a test of falsifiability. The experiments commonly cited as confirmation of general relativity also confirmed several alternative theories of gravity equally well. But an experiment that truly put general relativity at risk of being falsified has not yet been carried out. I will discuss such experiments once that supporters of general relativity prefer not to talk about in my upcoming videos. Science is fundamentally different from religion. In religions, dogmas mustn't be criticized. In science, criticism is not only allowed, it is required. If a theory is truly correct, criticism can only strengthen it. This is exactly what happened to quantum mechanics after Einstein's criticism. And if criticism destroys a theory, then why is such a theory needed at all? That is why any scientist who supports a given theory should welcome criticism and shouldn't be afraid to discuss it. Today I will analyze errors in the central equation of general relativity, the Schwarzschild solution. Together with my husband Yanchilina, we published a paper on this topic in a peer-reviewed scientific journal by Elsevier. The peer review process lasted an entire year, and the paper was finally published in 2024. 1 year later, in March 2025, I presented this work at the Global Physics Summit organized by the American Physical Society held in Anaheim, California. It was a wonderful time, filled with exciting events that brought together not only experienced scientists but also PhD students and university students. The remarkable nature of Southern California cannot leave anyone indifferent. It is not only the wide variety of palm trees, but also cacti, succulents, and other exotic plants. We even saw hummingbirds. Right near the building where the conference was held, we managed to capture this tiny bird on video, if only for a few seconds. But now, let's turn to the core of the topic. For those unfamiliar with general relativity, the Schwarzschild solution is the principal solution of Einstein's equations. It determines how distances and the rate of time change in the vicinity of massive bodies. This solution has become the cornerstone of modern gravitational theory. It is used to calculate the motion of light near the Sun and gravitational redshift. However, surprisingly, very few scientists, including experts in general relativity, have asked the following questions. What is the meaning of the number 1 that appears in this equation? Why does the contribution of the individual mass enter with a sign opposite to that of other masses? What does the event horizon actually mean? This question exposes the main pain points of general relativity, these deep logical contradictions. I will explain these contradictions and we will see how they can be resolved in a simple and elegant way. So, what does the Schwarzschild solution actually look like? It is an equation for the square of the interval. And the interval is a distance, but not in ordinary three-dimensional space. It is a distance in four-dimensional space-time. This is what the square of the interval looks like far away from large masses. Near a large mass, which we denote as m, this interval changes. Its square at a distance r from the mass takes the following form. This is the Schwarzschild solution. I agree, the equation looks intimidating. But don't be afraid. This is only because it's written in spherical coordinates. This form is optimal and convenient for calculations. Now let us return to the equation for the square of the interval. This expression can also be written in spherical coordinates r, theta, phi. Now let us compare this equation with the Schwarzschild solution. As we can see, the Schwarzschild solution differs from the ordinary equation for the square of the interval in only two ways. The first term on the right-hand side of the equation is multiplied by this factor, while the second term, on the contrary, is divided by the same factor. That is all. In general relativity, this coefficient in front of the c squared dt squared minus dl squared is the component of the metric tensor G00. This component determines the rate of local proper time d tau in a gravitational field. Here, dt is the time interval measured far away from the mass m, while d tau is the time interval measured at a distance r from the mass m. There is nothing complicated about this equation. It can be clearly explained even to high school students. It uses only the simplest algebraic operations, multiplication, subtraction, and square root. That's all. And the errors in the equation are simple and understandable to everyone except perhaps to supporters of general relativity, who can also understand them if they are open to dialogue. Incidentally, the first person to draw attention to these issues in the Schwarzschild solution was the American physicist Richard Feynman in his lectures on gravitation. He didn't resolve these problems, but he did point them out, which in itself is already significant. The Schwarzschild solution is considered the foundation of general relativity. However, upon careful analysis, internal logical problems emerge that scientists for some reason tend to overlook. These problems are not related to experiments. They are embedded in the mathematical structure of the solution itself and directly affect the interpretation of time, mass, and singularities. In the following videos, we will consistently and rigorously analyze all three key errors of the Schwarzschild solution and show why they are not minor inaccuracies but indicators of deep contradictions within general relativity. Thank you for being with me on the channel Bold Science with Firyuza, and for your interest in bold and free science, science without dogmas and blind reverence for authority. Subscribe, leave a like, and see you in the next videos.